And we are live. So, hello everyone, hello our dear audience. Thank you for tuning in on today's fifth and final day of AI Africa Week organized by Orange Digital Center. Since we have so many new people, new faces that have registered just for today, give me a moment to present Orange Digital Center for you. For those who don't know, the Orange Digital Center program brings together in one place a set of a set of free programs ranging from training young people on the latest technologies, supporting project idea holders, to accelerating startups and the investment in these. All this in order to support the employability of young people and encourage entrepreneurship. Each Orange Digital Center, or ODC, includes a coding school, a Solidarity Fab Lab, an Orange Fab Startup Accelerator, and the Orange Ventures Africa, which is the Orange Group Investment Fund. Now, a bit more details for those who are interested. The Coding School, which is a free access and completely free technological center of training, events, and support for developers passionate about new technologies and carriers of project ideas. The Solidarity Fab Lab is a digital manufacturing workshop for creating and prototyping with digital equipment. It's also aimed at this type of public, but also targets young people without diplomas and without jobs. Now, Orange Fab and Orange Digital Ventures Africa, on the other hand, are programs that target entrepreneurs. So I know that many of you are entrepreneurs through the registration form, so this may be interesting for you. Now, Orange Fab is a startup accelerator that supports the most promising and then commercial development and also helps them build commercial partnerships with the Orange Group and the worldwide network of 17 Orange Fabs. And the second, Orange Digital Ventures Africa, is an investment fund endowed with 50 million euros, which finances innovative startups in selective and countries on the African continent and in the Middle East region. Now, ODC, or Orange Digital Center, aims to create synergies between all these programs and is already deployed in Tunisia, Senegal, and Cameroon, and will soon be deployed in 15 other locations, so stay tuned. Now, let's go back to AI Africa Week, our most beloved event. We are really happy to have you with us, and we are really proud of this event, which spanned 5 days from January 25th to today, 29th, 2021. The first edition of AI Africa Week is a week of conferences, use cases, and practical workshops around artificial intelligence provided by a large number of national and international experts from the Orange Group, Orange Business Service, Business and Decision, and the various MIA subsidiaries on one hand, and national and international experts, including representatives from Orange, Google, Microsoft, IBM, Amazon, nvidia, Valeo, etc. on the other, for a total of 15 conferences, a program for all levels. We have already seen so many themes around AI, the opportunities, the limitations, open data, automation, the professions. And today, we will be focusing on the hardware part, the computation, and the infrastructure through 3 panels. So be with us. We have 3 awesome panels today. The first one is right now, which is gonna be hardware optimized for artificial intelligence with our dear speaker Isaam from nvidia. Then we'll go into the infrastructure and computing and strategy for data and AI with our guest speakers from Orange Group and Google, Mr. Steve, Jarrett, and Mr. Clément Moutet. And finally, we will finish this with next generation computing, where we will be talking about 5G. We will be talking about quantum computing, quantum machine learning, and we will see where the future will go. Now, all of this has been said. Let's get right in. If you are following this on the EVA website, then you can see that you have the choice to hear this either in French or in English. So if you are a French speaker, you can choose French. And that's why I would invite you to go and check this on the EVA website. Now that all this has been said and done, I would like to present our first speaker, Mr. Isaam Said from nvidia, who is a manager / solution architect at nvidia. Hello, dear Isaam.
Thank you, Elias. Thank you for this kind introduction. Happy to be with you today. and with all the attendees. I'm really glad and actually very as a Tunisian seeing the young generation in my home country trying nice things like this one, and I thank Orange for the invitation and for the initiative. And you can, as much as we are involved with NVIDIA, you can count on our help anytime.
Thank you so much for this, Isaam, and we are also really glad to have you with us. I think you are one of the best people to represent this panel, as you have so much experience in this and you know about it. And so let me like briefly introduce more, give more context about the panel. So we have already talked about the overview of AI in the first day. Then we moved on to the data needed, and then the algorithms behind AI. Yesterday it was the careers. But now one key thing about AI is that, and you already know it, is that it needs a lot of computational power to be done right. Not just to be done, but to be done right with all the high parameter optimization, the tests, etc. And so we have a big issue of hardware constraint and computational need for AI. Do you want to expand on this point?
Yeah, absolutely. I mean, I think today we're living in an era of data, right? So everything is connected, everything is interconnected. I'm not sure, I don't recall the exact study, but there have been a lot of studies, one of which is predicting that we'll have around, I don't remember exactly, 60 billion connected objects by 2025. As much as we have huge compute power across the globe right now, there is no limit. Data is a super linear problem to solve, and without actually making the most interesting, or making the exact, let's say, making the filtering and the selection of what you need or from your data, or make your data talk somehow with the help of artificial intelligence, we're not going to make it, because we cannot provide as much power as we generate data, right? I mean, you know it very well. Social medias across the globe, even in the enterprise, in the cloud, in media, in entertainment, in teaching, and especially now with COVID. I think you've been following all the digital companies, how they we have seen the importance of sharing data, and as you mentioned, delivering data in an efficient way, how important it is. COVID changed a lot of things, and that's probably one of the key outcome is the acceleration of digitalization. So you're right, compute power is not new. Is very much needed for data analytics, artificial intelligence in general, and the era we're living now is just emphasizing that point.
Exactly. And now I would think, do you think, first of all, so I would love to ask you personally, do you think that this need came more from the newest algorithms, or did it come from the vast amount of data that you have to process? Which of these points do you think had the most role in the rapid progress of hardware? Like now we are seeing, for example, graphics card. We have then tensor processing units. We have the edge TPUs. We have so many names for hardware, and some of them are specialized for fast data processing. Some of them are specialized for optimized on mobile and constrained devices. So I would love to instead ask where to begin. Like where to begin? What types of hardware is there for any AI practitioner? What should we know about the hardwares that are being used?
That's an excellent question. There are plenty of points to address here. The first thing I would say, why is it all of a sudden very important? I mean, it's very recent, right? This I would say this interest and attention around AI is actually very recent, right? Let's say the last 8 to 10 years. Okay. However, the AI algorithms, deep learning algorithms, are one of the oldest that we ever have, and has one of the simplest, well, I don't say simple, but let's say one of the classic mathematical foundation that have been existing for a long, long time. So why are we seeing all that? The answer to this is very simple. Actually, it was addressed by Jan LeCun in 1212, or I think, sorry, in 2012 or 2011, something like that. It's the combination of three factors. The first one, the huge sudden increase of data. And I'm sorry to say, like rubbish data, because social data, social network data is not the best data that you can use for science. However, it's there, and we have to process it, and we have to archive it, we have to analyze it, we have to do plenty of things. So the interconnected objects all across the globe just made this booming of data just happen the latest, I don't know, three to 4 years or 5 years, right? Now we have smartphones everywhere. We have connected cars. We have connected refrigerator. We have connected cameras. We have connected, domotics equipment all over the world. We have, apart from the classic, interconnected IT computers and supercomputers. The second point is the advent of, I would say, the advent of computing. Right? If you see the history of computing, and today, yes, it's a machine learning problem. Everybody's talking about machine learning, but if you analyze the machine learning, let's say, algorithm specter, it's a very nice, one of the most complex computing problem to solve, right? Because it's a very nice combination that needs extreme compute power, high bandwidth. High bandwidth memory, very fast interconnect, availability of the services, very nice engineering, software engineering skills, deployment skills, mathematical foundation. So it's a combination of one of the nicest problems to solve from an engineering perspective. So the advent of computing was always driven by the demand. In the 90s, it's a secret for nobody that oil and gas company across the world were driving the innovation in computing, and the reason being they are the biggest consumer of such compute power across the world. So they were implicitly they have been driving the innovation for computing. And as a matter of fact, if you're familiar with the classification of the biggest supercomputers in the world, there's a website called top500.org where there is a constant classification of the biggest supercomputer across the world. Many of them are actually owned by oil and gas companies, and that's the reason why. Today, that driver for compute has changed. Well, changed, or let's say evolved, right? Data is now the driver for compute, right? So technology companies just work so hard to just address that fast demand of data. And the third factor is, as you mentioned, algorithm. Not inventing new algorithm, as I mentioned, one of the oldest, but democratizing them, right? People like as I mentioned, Facebook Research Center, or Google, nvidia, or Amazon, or any other startups, find a way. Remember, who I don't know the audience, but who ever knew how to write a neural network before TensorFlow and PyTorch? Nobody, right? I mean, very few. But by the democratization of algorithms and creating those platforms, I mean, software platforms and SDKs helped a lot to democratize those algorithms and make the complexity a little bit higher, in the software stack, and kind of like abstract the complexity of those algorithms. So if you combine those three factors, that explains what we're living today.
Rapid growth and rapid progress of hardware, so fast that we may not even we don't manage to understand one, and up we find a new piece of hardware that came out. And that's actually a very interesting introduction that you gave us, because that's exactly what I want to lead this conversation, because not many know all the types of amazing hardware choice that we have now. Many of us know GPUs, of course, because we have them in our computers, but not many know about, for example, let's say clusters, or let's say TPUs, or let's say edge device or edge computing. So about this, can you enlighten us a bit, and especially give some choices, some idea to the audience about all the possible, not all, most of the possible options that we now have for AI? Because I do think it's interesting.
That's actually a very, very interesting point. In the history of computing, we all know. Let me try to find something. So we all know what the CPUs, right? So we all know that I don't know, when I remember back when I was in university or school, I just used my laptop, or my first computer that I owned was a Compaq in the 90s, and it was if I remember, the Intel MMX, which is I forgot the performance, but it was something around 256 kiloflop or something like that. The measurement of power is something that the scientific community developed for a long time, and it's unknown by the community. It's unknown by the let's say the final users or data scientists, or I would say application engineers in general. So floating point per second was for a long time the criteria to classify compute power. And whatever you have in your pocket, in your house, in your university cluster, in the cloud, is always defined by the same way. What is the maximum number of operation that this machine, this tiny processor, this huge cluster, or this huge entire data center can process an instruction per second? This is how we actually quantify the performance today, right? So if you follow the trends, I mean, in the 90s, we were talking about hundreds of gigaflops, and gigaflops is something like 10 to the power of 9, right? Instruction per second, which means that your computer or whatever you have in between your hand can operate that fast per second. Now, we are on the exascale era, which is 10 to the power of 15, I think, right? And we're going towards the 10 to the power of 18th. So can you imagine? I mean, I just don't imagine how many zeros after the one operation we can do per second. At some point, we were asking ourselves, what the hell are we gonna do with this compute power? So if you look at your iPhone, your iPhone today, it has 2 to 4, cores of ARM processors, and there are a lot of small startups. They're doing some compute on iPhones, and even some inferencing on iPhones. What you have is already a supercomputer in your pocket. It's amazing how much data you can process, or how much instruction you can do if you just forget about what you use it on a daily basis. It's amazing how much instructions you can do, right, from a scientific perspective. So across the history of compute, that power was used for general purpose processing, general purpose science, general purpose application engineering, and CPU was the de facto hardware. Intel just came to the market, and when they just came up with this technology, decades ago, and they kept performing, following one law that is called Moore's law, which is every 2 years we have to double the number of transistors that we can put in a silicon, right? So almost every 2 years, that's why, by the way, without us knowing, we buy laptops almost every 2 years, right? Or a little bit around that pace, right? Because we always seeking performance numbers, especially if you are a gamer. And that's actually, we're following that classic law that was stating every 2 years we can increase the number of transistors by a factor of 2, and then we deliver almost twice the performance of the latest generation. So in the scientific community, where they were adapting the same trend as the consumers. So when you work with a cluster or when you work with a academic institution or a big company, you always have a supercomputer in your premise, and that supercomputer was always composed from interconnected CPU servers in a large number, and it was doing exactly what all engineers were tended to do. So if you are a C++, Java, C developer, whatever it is, it's actually was used for general purposes. Now, when supercomputing was a thing for the first time, people challenged this law, right? So we actually physically cannot put as much of as transistors that the silicon die can support. This is when things started to change, right? I think that was the inflection point, even before deep learning and machine learning. As I mentioned, we're always, application is always driving technology to progress. But here we were facing a physical wall. And in other words, just to explain to the audience, if we want to make CPU more dense, it would just go on fire. We touch the limits, so we cannot cool it, right, enough and make it ambient enough so that you can maintain it and use it, right? So we touched a physical wall. That's why, by the way, multiprocessors or multi-cores was invented. So instead of like making sure that we put as much as of transistors in one core, the idea of Intel at that time and AMD was how can we make many of them and interconnect inside the chip. Even with that progress, we also hit the wall. And by the way, that wall is important because that wall is defining generations of applications, right? So when we reach a certain wall, that's actually where pushed, technology companies for innovation, but in the same time, the data and the nature of application also helps to go different routes. Now, engineers and researchers started at that point to go different routes. One of which was, of course, GPUs. So for the small history, GPUs have been used for gaming for a long time. And if you compare a GPU versus a CPU, you can say that a GPU is a very stupid CPU version, right? Very simple. It has very little intelligence in the silicon, but it can process data in a very high throughput. As compared to a CPU, CPU is a very complex design SoC and a very complex silicon that can do complex tasks. So if you have something that you will run and it's simple enough, or the mathematical foundation of it, of which is very simple to describe or to code, GPUs was invented for that. But GPUs were not considered as the main horsepower of the data center. So it was kind of like an extension. So GPU was not the only route. So people discovered that they can actually have what we call them accelerators, or as you mentioned, special hardware to add on to a classic cluster or a classic compute platform, right? So things like FPGA came to the market at that time. It was always for simulation purposes, as I mentioned, for high performance computing and supercomputing. When things come, when AI, as I mentioned, was the hardest topic and the hardest application to solve. Now it was yet another wall that we just we discovered another wall. This time it's not a silicon wall. The silicon wall will come with a quantum computing, right? That's why people are trying now to prepare for quantum computing. Guess what? They are already preparing for the next physical wall, when GPUs or sophisticated hardware is no longer good. This is the next physical step, but we're not there yet.
Yeah.
But however, we have a different wall. We have a data wall, right? So, sorry, can you hear me? Can you hear me well?
Yes, we do. There's just a really small noise coming from your microphone, I think.
Okay. Is it better now?
It still exists, but it's not that much. It's not that much of a problem. So.
Okay. Sorry for that.
No
so that wall, the data wall, just pushed for innovation in a different ways. So, I mean, we can go later in detail, but the core idea of those sophisticated hardware is people found out, or scientists discovered, that okay, most of what we do in deep learning has a couple of a core application or a core algorithms based on a very simple algebra foundation. How about we do an accelerator for that operation? That's why we came up with the tensor cores for in our case, or TPUs, or the neural processing unit by IBM at some point, or what we call the tensor processing computers, like a Graph-core, I forgot the name, Nirvana, and so and so. The idea is always the same: is let me pick the core algorithms that are used in deep learning, and let's accelerate them to the bone and build a hardware dedicated for that, and then provide it to the market. We can talk about the pros and cons later on if you want, but that's like a history.
That's like a really comprehensive history of hardware progress, and I really love the analogy that you gave about application is what's driving the progress behind it. So I really love that. I actually forgot about this whole event. It was so focused on the story that I forgot there has to be more questions. But there is one actually. It's this one. Do I need now, as a new person, as a company, as someone who's working in this sphere now, do I need to have such specialized hardware at first? Do I really need to have a supercomputer? Like, what hardware should I start with? So this is one of the biggest questions that we have from startups that are working in machine learning. They think, should I get on-premise computer? Should I get a cloud resource? Should I get a server? Should I just work with on my own computer? So you gave a really interesting idea, which is the amount of flops. So maybe you don't need that much processing. But also at the same time, the common people or people who are not familiar with hardware do not really understand how many flops they would need. So would you have a small recommendation or a small roadmap or guide which can help people choose the best hardware for their use case?
Yeah, sure. As an application developer, I think we first, let's say as an AI practitioner, I like all the buzzwords that just came out in the market, but at the end it goes to the same definition, which is a just sophisticated software engineer. But I like the titles that you can see in LinkedIn. But choose anyone. At the end, what we do, it's some software engineering somehow. As an AI practitioner, wherever you are in the stack, either you are from the business side, from the application conception, to the application performance enhancement, to the low-level tweaking, to the hardware design. If you are in this scope, the first thing you need to know is what is exactly that you're trying to achieve, right? If you are trying to solve a problem for a customer, let's assume a startup that wants to do like something around, automatic plate recognition in Tunisia, right? And then they want to provide the solution for the police, the national police, right? As their problem is different from my problem, which is I want that object recognition algorithm runs as efficient as it can be. So, and the problem of whoever will receive the deployment of such an application is also different. And the one that has to buy hardware for this application is also different. So now, if you are on that top of the stack, and if you want to solve problem, your compute power, I mean, I'm probably going to shock you with this, doesn't matter. That's not your number one priority, because with what you have around you, with the cloud providers or with the partners, either the local partners or the global partners, you have everything you need to start from day one. And actually, I mean it very well. Like anybody that wants to build start at least a proof of concept, and I don't know, a couple of clicks and probably a very minimum investment, you're already running. You're already running. If you have your team, you're already running, and you can go, right? So so if you are on that specter, don't focus on your compute power. It's not your number one priority. The question now is, when should I focus on that? And when I have to ask myself that question, you need to just ask me. It's the quick answer to that is when you are in a very, let's say, advanced level on your project. Either your startup, you're not in the first step, you're in the second or the third step, and you're trying to scale. Either you're trying to scale, or you're trying to study your finance, your investment. What is your ROI based on your solution? And this is where you will be looking at where should I run my application. Let's go back to that. It's the same example. Now, let's assume Orange came up with a solution and they want to sell it to the national lab. So I'm pretty sure that in the first, the national police, the first time they will probably try in AWS deployment, right? And then you come and you said, okay, listen, I did a study. Actually, we're losing money. We're losing money because, I mean, again, nothing against it, AWS. It's a very nice platform to start with. And then you said, okay, we're losing money because we're now scaling and we're charged by, I don't know, the number of GPUs I'm using or the number of requests or whatever whatsoever. And you do a study and said, what if can I have the capability to build my own cluster and reduce the charges? And this is, you need to do like a sort of a study, right? And let's say, okay, this is my scaling projection from a user perspective. This is my budget. This is my possible solutions in terms of capacity. And then you go and you study the market, and you say, okay, for this particular application, what should I build? Should I build a GPU cluster, TPU cluster, whatever? I mean, I'm not sure you can build a TPU cluster, but it will come at some point, or a graph core or FPGA or whatsoever, right? That should be, this is where exactly you will be tweaking the deployment of this application. And that's why, by the way, there is an object detection, and even in Kaggle, there is plenty of competition. Now, the competition is not only about accuracy, but also about time, execution time. How much time should I spend in training my model, and how much time should I spend to run my inferencing?
Yeah, so it really depends on the use case, as you said. So you might need something that's more on a cloud, or maybe you're somewhere offline, you work in IoT, and you need something that's more like not related to the cloud. So in that case, you need on-premise. You need on edge. In that case, could you give us a small, non-exhaustive list of the options that we have with small explanation? Like we say, we have GPU if it's feasible on one computer. You might need some cloud resource if it's bigger than that. You might need a cluster, like for example, NVIDIA's DGX, if you need something, a bigger problem with a big team, or if you need a TPU, an on-edge device, for example, for something that's, for example, an autonomous driving car. So can you give us a bit of an example of the landscape of options that we do have from a cloud, from on edge, from on premise, so that we can have a better idea of what we can invest in?
Sure. There is today, if you look at what's existing on the market, I think it's secret to nobody that Google, Amazon, and Azure did a very good job to democratize access to compute power. And when you go to, I don't know how familiar you are with those instances, but if you go, today you can find instances with very fast CPUs. You can find instances with different range of GPUs. When I say range, different compute power of the GPUs. So as you mentioned, and they are very smart. They actually charge you with respect of how fast you want to run things, or how big you want to run it. So we call this, super scaling or hyper scaling, right? So do you want to run one task as fast as you can, or you want to run as many of small tasks as you want, but you don't care how long it will take each one of them, right? So the approach is different. And for both, you have offering today on the cloud. Basically, there are CPU instances, GPU instances with a different range, of power, and you have today TPU instances when it comes to GCP. All right. So I don't think that on the cloud you have any, for the time being, any offering based on specialized hardware for AI, things like GraphCore all the time. I think that's the best example that everyone can refer to. These things are, if you're looking at, if your business is, or if your solution is something very related to the, I would say, to a another commodity. By commodity, I mean if it's related to a car or to a drone or to a electrical equipment or a camera or I don't know, anything you can imagine, right? A robot or a surveillance system. If your business related to such thing, to a commodity, then that's for sure that from day one you have to go for the specialized hardware, because you have to not accelerating AI is not the only it's not the only feature that you're looking at. You want to hardware that connect very well to your sensors, to your cameras, that can be used air gapped, offline, not connected. It can be used in a very harsh climate conditions. It can go. It can run on water and heat, on sand. So different component, right? But if you are a practitioner that works on a full software solutions, like things like object detection, segmentation, classification, regressions, classic tree-based machine learning, you go to the cloud. That's what you find today. You find either fat CPU nodes, instances, GPU instances, and TPU instances. You have no other choice as of today. Now, as a company, as nvidia or AMD or Intel or any other tech company or even Amazon, as I mentioned, in an advanced stage of your investment or your work, you may notice that cloud is no longer a solution for you. If you want to control your audience, if you want to control your interactions, this is when and only then you start to build your own solution, and you try to build it in such a smart way that actually it can be used as a cloud. Think about it now. Actually, on-premise or cloud is still cloud. By that I mean, today, our customers, for example, if they invest in their own software, on their own hardware, the software stack is also a software stack similar to what you can see in Google or in Amazon. In other words, it's a Jupyter notebook running on Kubernetes or running on any task, any task manager. Okay, so even if it's on-prem, it's a private cloud for you, and that's what software engineering is going now. Everything is containerized. Everything is using orchestration technology like Kubernetes or OpenShift, and even if you're using it at home, most of the developers, they use the same techniques. So moving from on-prem to cloud or vice versa, from a software perspective, is having less and less cost. So it's not like you need to reshape your code and everything. No, you just move your container from one place, put it in another. You should have the same thing, right? So
it became like a drag and drop game now. You have one code, and then you just choose whatever option is better for you from the needs, from your scalability, your availability, etc. And I think that's one of the biggest paradigm shifts from the past, where you had to choose one stack or one piece of hardware, one server, put it in a room, keep it cool, etc. And now you can just in some clicks fire up a server somewhere in the cloud. But also there's still a problem on that in terms of privacy. So if you work on some private data, then you might need to have some hardware that's at least in your vicinity or in your country, and cloud would be a problem for that. And that's why I think you would need some on-premise, like a server, real server or something else. So there's still that problem, right?
That's true. Data sovereignty is also a point that I forgot to mention, that you're right. Some of the governmental institutions, for example, cloud is not an option for them, or military organizations, right? Therefore, the choice is quite simple for them. But even though, as I mentioned, they still have to adhere to the new trends of software development, right? They have to use the new ML ops, DevOps approach, where you should package your coding or your codes and your solution applications in containers, and even internally to ship it from one team to another. That's changed the IT in general, right? Even a system engineer today is no longer the system engineer that will fix a network card or a CPU or replace a GPU or replace a disk. That's no longer the case. A system engineer now is an engineer that will make sure that the training is generating the same accuracy, or an inferencing is generating the same score, right? So as you can see, the stack has been, the limit is less and less defined.
True that. And as far as NVIDIA is concerned, so can you tell us a bit more about what type of hardware options you offer for people who are interested? So I think there are so many GPUs, there are clusters, there are the DGX super servers. Well, can you give a more insight about the options that you have at NVIDIA? And what type of interest?
How can I share this screen now? Let me try.
I think it's in the bottom. It's a green button.
Okay, yeah, I got it. Do you see my screen?
Yes. Wow.
So before showing you, what we offer, I mean, again, I'm an engineer. I represent the company here. I have no interest. It's just a disclaimer to show you what we have. But I just want to explain to you from a technical perspective, how are we addressing the challenges that we see in machine learning. It's a pity that we can't interact with the audience, but if you look at what is needed from a hardware perspective to run a training algorithm fast, you need a processing unit that can manage matrix computation, which is the foundation of every convolution. The matrix format of the convolution is at the heart of every deep learning algorithm. So you need something that will accelerate that, and that actually gave birth to all the tensor processing unit that you see across the world. The idea is very simple. Instead of, as I told you, in one clock, in one hardware clock, you're doing one operation. That's what how every silicon works in the world right now. In one execution clock, you do in reality, it's not only one instruction, but it's a couple of them, or 4 or 8. It's a very limited number. You do a matrix multiplication in every clock. That's what the tensor core is doing. So as you can see here, this thing here is showing you that instead of doing like A times B equals C, and from a scalar perspective, it does all that operation. In other words, it will do that cube that you can see here in one hardware clock. This is where the acceleration of deep learning from a tensor core is coming. That's the secret. It's actually not a secret. It's just a very obvious conclusion that every technology vendor came up to. All right. Now, that's what you see here on my right-hand side. That's the GPU from a silicon perspective. Okay, so this is the NVIDIA GPU. We invented something new. It's called the NVLink. So NVLink is what we discovered is that, as I mentioned, a GPU is not standalone, so it needs to get connected to a CPU. The old technology, which is called PCIe technology, was a very slow bus that connected CPU to GPU. When you run machine learning, you actually, or any supercomputing or high performance computing algorithm, that's actually a bottleneck. So we came up with another interconnect that is almost 10 times faster, if not more, than that bus, to interconnect multiple GPUs altogether. Right. So now what we're trying to do is that, as if you have a much bigger GPU when you combine many to get all together. Okay. And the last thing that we added is a high bandwidth memory. So the memory that you can see here on top of the CPU, on top of the silicon, it's called the HBM memory, high bandwidth memory. Just to give you, in order of magnitude, if you take a laptop today, those RAM that you see, okay, or your computer, those memory, maybe those bars that you can see in your computer, this is the classic memory, right? The DDR5 or 6. This memory here is probably, I don't remember, but let's say sustained, it's more, it's something like around 20 times faster. So as you can see, if you combine fast memory, high bandwidth memory, faster intercommunication between the GPUs, and an acceleration of compute, which is coming from the tensor core, this is how we kind of like came up with a very complete solution that will address deep learning and take it to the much higher level. Now, we didn't stop there. NVIDIA started to build the GPU, and then we discovered that we need to go more, and we need to move from a chip company to a platform company. And that's why we started to build our, our own server. So this is the blade that you put in the server. And those basically 8 of the GPUs that I just showed previously, all interconnected in the same, let's say, we call it a blade, or this plateau that you see here, 8 of them interconnected with this high bandwidth, as I told you, NVLink, this new technology, okay, and all packaged in one simple server that we call DGX that you were referring to. This is our flagship product. I don't know if I have a picture of it in real life. Anyway, so let me go back here. And we didn't stop here. So if you go to the back of the server, we said, okay, now we build the chip, we build the server, but we need to put all these together in a real life scenario. So now came the communication outside the server is also important. Do you know why? The answer to that is very simple. When you do backpropagation, it's a lot of gathering and scattering of weights. You have to do what we call a gradient aggregation. If you try to do the backpropagation in multiple servers, it's actually one of the most challenging problems, because when you do the gradient on the backpropagation, when you calculate, you can find local minimas in your server, but you have to do a certain of a handshake to all the servers to find out where is the global minima. The global minima, so that you can decide what is your misfit and then go to the next iteration. This is the most compute powerful piece of the algorithm. So without a very high network, you cannot achieve, or let's say you still can achieve whatever you want, but you cannot keep up with the compute power that you have with what I just showed you earlier. That's why we added network cards with a technology called InfiniBand. I don't know if you're familiar with this. And we put 8 of them. This is the highest, let's say, density in terms of interconnect that you can find on the market today. So basically, for every GPU, you have one network card that is working for that GPU, right? And you can imagine how fast this can be in a cluster environment. And then we came up with something called SuperPod, which is what you see here, is actually how can we interconnect all these together for the customer and give him a turnkey solution. We do everything, even the network, which was a company called Mellanox that NVIDIA bought. It is now an NVIDIA company. So we manage everything from the chip to the cluster platform all together. Now that very same GPU, the technology that is built on the GPU that you put in the data center, this one, is also implemented in smaller GPUs. I don't know if, let me go back here.
Oh, this is like a heavyweight. This is really like a heavyweight. And is this already available to the public?
Yes, it is. So let me go. There is, I think, a slide here showing all the platforms. Yeah, here. So we have different ways, different forms of those GPUs. So you can use them in your own cluster, or this is what we give to Amazon, for example, to GCP, to Azure to implement. But also we have the embedded ones that go to edge compute, which we call Jetson. I think I don't have it here, but I can just Google it simply. Jetson.
Jetson is becoming more popular, especially among us, among embedded fans. So
Yeah. Yes. So the Jetson, that's a Jetson, for example, Jetson Nano. This is for academia and for small startups, for beginners. That's actually a very nice module. I mean, I think it's available everywhere, and that's actually what you see. Look at this. This is the chip, right? And we have different forms of them. This one here, which is basically this one is what goes to every edge computing device. It's the same technology, but is embedded in a very small GPU. Of course, without the same compute power, but this is what every embedded robot or drone can use. This is a developer platform. And in a drone, you will stick only this, okay, just for sake of it. This is what goes to the cars. Any autonomous driving car that we do, what we build with Mercedes, for example, Volkswagen and Toyota and Ford has this thing inside the car. This is what drives every autonomous car within our partners. So what I wanted to emphasize here is that we don't build different architectures of the GPU. It's the same. It's the same technology, but we provide different forms. Okay, so whether you wanted to use it on the edge, whether you wanted to use it on the cloud, or you build your own, or completely acquire a cluster, a turnkey cluster, you can have that, and you can find somebody at NVIDIA that can help. Okay, so back to you. I don't wanna.
No, I was so focused on it. I loved how much advancement there is, and especially for the last part, the last part. So you've shown us so many great products from the Jetson, from the clusters, from the GX cluster, from the singular A100. I would love to ask you, so is there any way for startups to try these out? Are there, for example, open demos on cloud, or, for example, do the startups that partner up with you in the Inception program have access to some of these unlimited space? And at the same time, could you please introduce the Inception program for all the entrepreneurs that are watching this right now?
That's a good point, and thank you for reminding me. I think you, through your relationship and previous experience, you have actually experienced it. There are many ways how to interact with NVIDIA in as like step zero without a lot of investment, because NVIDIA addresses developers at the first time. We're an R&D company. Most of our staff, 90% of our staff, are engineers. We don't invest a lot in marketing. It's known that NVIDIA, we want to work a lot with developers. I have to say, from a personal perspective, I am, when I joined NVIDIA, I knew that it's, as a US company, it's something that very oriented with the US technology and working with US institutions, US universities. And then I discovered that we're actually growing, working with multiple academic institutions across the world.
Sorry to interrupt.
Yes.
The noise has become a bit bigger, so there's a big noise with the microphone. You can just like turn it off and on again, maybe.
Let me try.
Or just switch to another microphone if you have one.
How about now? No?
I think it's the same thing. Can you test? Can you say something for us to test?
Hear me now?
Yeah, now we don't hear you.
Can you hear me now?
Yeah, we do. However, there's still the noise. I think we can continue, but just if you can speak a bit slower, it's for the interpretation and the real time translation.
Okay, okay.
Uh,
Okay.
we still have
So,
it's together, so in those
I
last
apologize for that.
yeah, just speak a little bit slower.
Yeah. So, I have to say that we don't have enough engagement with Africa in general, and we're trying to fix that. So, Inception program, as you mentioned, is one of the best known program that we put together, which is the involvement of NVIDIA with the startups, emerging startups, and well-defined startups, let's say. The idea is how to help those entrepreneurs or those AI practitioners that they are starting to address their compute need with a very small cost. So it's how to attract those startups to work with our software technology, not hardware technology. And in the meantime, we help them either acquire with special conditions or use our partners' software stack and hardware offering. That's the idea. It's called Inception program. There are conditions how to apply. Everybody's open to do it. And the other thing is just to be complete is what we call teaching programs with universities. Universities has also the possibilities to apply for research grants and to hardware grants with NVIDIA. So also there is forums to follow. I can help you finding those and broadcasting to the audience.
All right, nice. So, and all this can be so for the audience again. It's called Inception program for all the startups that want to have NVIDIA support. And I think we already have one of our speakers at this event, which is the Neurodata startup. It's already part of this program of NVIDIA called Inception program. And then there's also the teaching program, which is very interesting to check. All right, so now I would love to finish this panel because we're already at the end of this panel now. I would love to just ask you one last question, which is, where do you see from your perspective that we are now heading to hardware size? Are we going to be more specialized, like special hardware for each special use case? Or are we still going for general bigger compute or more optimized compute? So can you give us a small insight from your own experience on this?
I strongly do believe that we will be in a very mixed environment going forward, and I am unfortunate to say that it will be hard, more and more, let's say, complex to choose. The reason being is that use cases will never look like each other. There will be always need for dedicated hardware, especially with the rise of edge computing and edge devices. We will always have, we will see that. And by the way, we have seen a lot of startups emerging for that. Okay, and the more generalized hardware will continue to exist and continue to innovate because the software-based solution, as I mentioned, if you're working in a startup that is only doing software and offering software, do not really care about where is it running. So the cloud providers and companies that will be working on hardware for AI will always address that market, and that market will only grow. So I would say I don't think that we should focus on what should they use or how the hardware scope is progressing. We just have to accept that we will see more and more diversification, and we have to live with it.
Right. I think that's the most realistic, and I think that also I agree with this. There will always be mixed feelings about this. Let's just hope that we can do better, especially now with the newest technologies like with quantum machines or with even even better bandwidth with 5G, that we can manage to do that we can either manage to have better hardware, or we don't need to have, we don't need to focus only on the hardware, but more efficiency from the algorithm phase, from the data phase. In that case, we need less compute to do. So with this, I would say thank you so much, Isaam. Would you have a last message that you want to pass on to our dear audience here? So just to remember that many of them are students, many of them are entrepreneurs, many of them are AI practitioners, as you said, but we all love AI. So would you have one last message that you want to pass on to this audience of ours?
Absolutely. I really want to address the students in particular. I would say, no matter how hard it is that you feel sometimes frustrated. I lived in Tunisia, I studied in Tunisia. I know how things are in Africa in general. No matter how frustrated you are, be ensured that you live in exceptional era where you have everything on the tip of your hand or your finger. Compute, learning platforms, mentorship, funding, investment. I think you are living in a very exceptional era, regardless of how hard it can be from a country to another. Take advantage of that. Take advantage of that. Use the power that you have around you. If it's human power, compute power, or finance or funding. And COVID changed things drastically and actually showed no matter where you are, you can make a difference. So my advice is take this as an opportunity. Take it as an opportunity and choose to fail now before you build a life and a responsibility that will hinder you from doing so. So just take the risks, reach out to your people, ask for help if you need. And also don't forget that you are a source of an inspiration and learning opportunity, even for old folks like us.
Thank you so much for your time and for your effort and for this kind message. I do hope that everyone that's here takes into account this, and you are one of our success stories. And we would love to see you again in future events. Thank you so much, Isaam. Thank you so much for your time and your effort.
Sure thing.
And with this, we have finished the first panel, which was focused on the hardware that's needed and optimized for AI, with our keynote speaker, Isaam Saeed, manager and social architect at NVIDIA. And now we will be going to the second panel, an also equally interesting panel, which talks about how AI is a greedy technology in terms of infrastructure and computing. And we are pleased and honored to have with us two big speakers. We have Mr. Steve Jarrett from Orange Group, which is the global head of data and AI. Hello, Steve.
Hi.
And we also have, nice to meet you. We are really happy to have you with us.
That's my pleasure.
And we also have Clément Moutet from Google, which comes from Google France, Google Cloud from France. Hello, Clément.
Hello.
Thank you so much for both of you for having accepted to be with us in this event. So we will start now with a keynote by Mr. Steve, and then we go with Mr. Clément. So, Mr. Steve, are you ready?
Yes, I am, and I'll share my slides. Is that all right?
Yes, please do so. We really want to know more about this, since both of you worked on data and AI on a big scale, and now we're not just talking about small data, small AI. It's really a big problem. We would love to know more about how you are trying to address this problem of computing, of infrastructure. How should you put strategies, and what you can do with this on a global scale. Mr. Steve, the stage is yours.
Great, and I look forward to your questions too. So I'm Steve Jarrett, and I'm the Senior Vice President for Data and AI in Orange Group. And so I work on our data and AI strategy across all the many countries and business units that we have. And really the challenge for Orange today is, how do we transform ourselves into being a data-driven and an AI-powered telecom company? And this is not an easy transformation. because this has a lot to do with understanding not only a bunch of digitalization and software skills, but also it involves thinking in different ways and really using data to drive decisions all across the business. So the reason why we have to do this is, there's many reasons, but the first of all, we have to use data and AI to improve the experiences of our customers, to make their experiences better, and so that we retain customers, and also that we're providing services that are appealing to them, that they're happy with one service and so they purchase another, which is really at the core of the business model, to cross-sell many businesses, many services. We've got to master the complexity of the future evolution of the network, which is really all about virtualization and containerization. The third challenge is, if we're not good about this transition, there will be new entrants. I don't know how many of you are familiar with Rakuten in Japan, but they're taking a very innovative approach to a cloud RAN, and they're early and they're late in many ways, but the ideas that they're working under, we believe, are really transformational for how to run a network. And so in the future, there'll be many more of those kinds of networks run by many different companies across the world that will be our competitors. So we need to be more agile. Then we need to make, AI is really about enabling, internally enabling people to make better decisions, and using AI to help you filter down the information so it's more manageable, so that humans can make really great decisions. And then lastly, if we do those things, then the company will become more agile and more efficient, and as a result of those two, more profitable. And that's really at the heart of the transformation. So just sort of briefly about Orange, we place data and AI at the heart of the innovation model for the whole business. We have these 4 pillars that we define for our plan between now and 2025. And so we turn those into 3 use case areas: smarter networks, reinventing the customer experience, and improving our operating efficiency. But underneath all of that, one of the things that I'm really proud about Orange, and why I came to work here, is that the company's really serious about doing these things responsibly and sustainably. And your point about this talk, how do we do this in a way that's efficient and recognizes that some of these methods consume a lot of power, for example, a lot of computation. And Orange takes that very seriously, not just in data and AI, but across the whole business. I don't know if you're aware, but many of the reasons why 5G has many power savings modes is because of work that Orange did very early in the standardization process to ensure that that was the case. And as we move forward towards 6G, we're really driving for the same effect, because we feel a serious responsibility for not only for our own business, but for the planet. So, why is AI back in why is it cool again over the last 5 years? It's sort of, for us, it's about these three trends. The first is that we just continually see an explosion of the data, but at the same time, luckily, we see a dramatic improvement in the density of storage, the availability of computing power, and the business model that was invented by Amazon and now deployed by Huawei and Microsoft and the partner that we just announced, Google, to allow us to have access to this kind of computing power on a rental basis, which is extremely useful. And then lastly, there's just been tremendous work. I used to work with Jan LeCun at Facebook, and his work, it's within a generation that we've gone from the ability to just identify very simple MNIST style text to where we are today, which is an extraordinary achievement in just a few decades. So we see this. All of these trends are leading towards this opportunity, and in terms of machine learning, the training phase, as you all know, is really, really difficult. But we see new opportunities. Auto ML approaches enable you to even go as far as contribute your problem and let the computer determine which even potential approach, machine learning or deep learning approach, may be relevant and most effective for a particular problem. and to be able to do that in 10 or 20 minutes. That's the kind of challenge that would have taken a human engineer a year to do, just months ago. So I think we're going to see continuing improvement in programming tied with computing power availability that will continually improve our efficiency to do this. And that's not just in terms of power efficiency, but it's also in terms of people's time efficiency. And enabling that are hardware optimized processors, the GPUs that come from NVIDIA and others, but also we see really interesting advances
Just to be sure. Okay, so yeah, Steve, you're muted.
Did you lose me?
Yes, just for a second.
Oh, I'm sorry about that. So what was the last thing you heard?
Well, to the event, can you go back to the slide? I will tell you where exactly.
Okay, sure. Let's see. Are you still seeing my slides or not?
Not at the moment.
Oh, I'm sorry. Let's see.
Yeah, so let's see. It stopped somewhere.
Did we stop on this slide or was it on the slide after that?
It was after that.
This one.
I think it's even the after this, I think. Or
okay, well, this was the
last one.
I didn't go any further than that. So did you hear me talk about AutoML or did you not hear that?
We heard you talk about hardware optimized processors.
Okay, great.
So it's in the cloud, l'ACC part. Okay.
All right, sorry about that.
No problem.
I'm not on Orange's network. I'm in London, so it's it's someone else's problem.
Yeah, very good.
All right, so yeah, so tensor processing units, I think, are really a fundamental advance because not only does it give you the ability to do the tensor mathematics extremely quickly, but also very, very power efficiently. And I think the other thing that people often don't understand about public cloud is that most of the public clouds are carbon neutral already. They're usually very close to extremely to power that is kind of ecologically responsible power. So whether it's solar or hydro or nuclear or others, and it's also so I think it's both a really nice balance of the need for us to have this computing power with power efficiency tied to relatively clean power. And then the point I mentioned before about elasticity, the idea that we don't have to build enormous on-premise data centers because training is really spiky. When you need to train an enormous model, that usually requires an awful lot of computational power and memory, but we don't need that for inference, for the usage of the model. So being able to rent that from providers like Google and others is really extremely useful for us. Okay, and then I think the other 3 points to make here. The first is that there's a bunch of opportunities to optimize the power consumption. I mentioned TPUs, but there's also a lot of really great work to do mathematical optimization itself on the way that you do training and the way that you prepare data, including preparing really messy data. And so actually on the third point there, doing approaches that are between totally unsupervised and supervised learning, where you can approximate the supervision by using these methods to identify outliers in data and to improve the quality of the data that you're feeding into the model. And so at Orange, this is an area where we're investing, and we're working with some really interesting startups. There's one in California called Snorkel that spun out of Google and Stanford, who's helping in this domain, because we have so much data that comes from the network, for example, that's really noisy and that's poorly labeled or difficult to label. And so these kinds of approaches are also, I think, really fundamental. And to the middle point, I think, making the model is the easy part. The really hard part is on the front end to get the data collected and gathered and maintained, to assure quality, to look for drift, and to assure ethical compliance. And then the other hard part is at the other side, which is after the model's been trained in deployment, how do you make sure your model's accurate and that over time you're maintaining the model and updating the model appropriately. And that whole process, end-to-end process, is so young. I mean, we're really at the beginning of the kind of industrial era for AI. It's just within the last year, really, maybe 2 years, that we've seen really significant advances in that domain. And so I'm really excited about the opportunity there. Because in practice, running AI models in your business at scale is hard. It's very much, for me, like the transformation from pre-internet to the internet area, where you're trying to transform your business into how to leverage the internet in your business. And as you can think back 20 years, 30 years ago, there were no good tools for e-commerce, for example, and for payment, and for fraud detection. And those same kinds of infrastructures for AI were really at the dawn of that next era. So I think it's a really exciting time. But there are many, many challenges to running these systems at scale. So how am I doing on time? Do you want me to talk for another 5 minutes maybe, or?
No, we're good. We still have a total of 12 minutes. So
okay.
Yeah, we can do this.
Okay, great. So let me tell you a bit about the Google deal that we announced. This slide actually came from Vodafone. So Vodafone did a deal with Google about 2 years ago, maybe 18 months ago now. And they presented why did they do the deal. And I thought the slide was so good and so accurate that I borrowed it. Thanks to Simon at Vodafone who gave the slide to let me use it. So on the left, you see, what's the current situation? And this applies for every business, really. You're not efficiently using your resources. It's hard to scale when you hit impacts. You have outdated technology often. You have a lot of in-house frameworks that you've developed. You're often competing for resources because you have limited computer scientists, but also you have limited compute resource. And there's many, many different data lakes and data warehouses and data sources. But for me, really the critical ones are security and privacy. And that one we take extremely seriously. And then the other issue, the really fundamental issue for me, is it's really hard to find great people. And building a really great team takes a lot of time and energy and effort. And so we've been lucky to recruit really amazing people, and we have great people from the history of Orange. We've always attracted and retained great R&D engineers. But if we're unable to allow our data and AI people to focus on adding value and feeling really empowered because they don't have the best tools and because they're constantly faced with the challenges you see on the left, we're not going to be able to retain those people. And that is a really fundamental challenge for any company. And so for us, this applies to all of the cloud providers, okay? But for us, the ability to scale up and down, provide the best tools in the world, allow for resource isolation, but where we have unlimited resources available when we need them, if we're willing to pay. But also the ability for us to have a really uniform environment for data security using great data governance infrastructure, and also this approach called policy as code, which is this kind of idea of taking the DevOps approach that you would take in software programming and applying it to your ML and AI workloads, where you can really manage and maintain the workflow of an ML or a project. Like ML ops is the term to describe that. but that also enables you to have great auditability and be able to look back in history at the sort of what has happened to your data over time. What is the provenance of the data that you have? Which is really difficult today in environments where you have many, many disparate systems. And the last point, again, is for me the really critical one, which is we free up these great engineers that we've hired to be engineers, not to have to also be a security person and a data protection person and a database architect. And like, it enables them to focus on their job because they have great tools and have clearly defined environments to work in. So for me, we had to do this kind of deal to give us this flexibility. So I'll just cover this slide very quickly so we have plenty of time for questions. As I mentioned, the points that I described, we felt like Google had a great solution for those challenges, particularly in hybrid infrastructures. They have a platform called Anthos, which provides for relatively seamless support for workloads that are on-premise or in GCP, as well as workloads that we would want to run in other clouds like Azure or AWS from Amazon. And so that was really appealing. And they also are a leader in this domain of MLOps. They've open sourced both Kubeflow, which was an infrastructure they used internally very early, and also TensorFlow and TensorFlow Extended, which is the MLOps environment for TensorFlow development. And so we felt strong about that. The other thing I personally also liked was they take very seriously contributing to open source, and then offering the open source contributions as their service offerings. So we could contribute in the open community and potentially deploy on our own premise if we wanted to, as well as use that same technology on an offered, a service offering from them in the cloud, which I really appreciated. And we're taking this test and learn approach, which is a lot of this is new to us. A lot of these technologies are new and approaches are new. And so we wanted a partner that would test and learn with us to identify architectures that work that then we could invest and scale. And both Google's internal kind of philosophies is around that, but also they seemed very open to supporting us and working in the same way. So that was really encouraging. So,
all right. Thank you so much for the slides. I really enjoyed it. Like I felt like watching a video on YouTube. I was like into it. Like this. I forgot that I had to moderate and ask questions.
Great.
So you said a lot of interesting things, from the advance in the change even in strategy, from talent retention, privacy, which can be fought with federated learning, distributed training, so many things. And especially I've loved how you focused on the impact of all of this and how we can use this to do impactful things and useful things. And so I would love to ask you, since you have worked with enormous amounts of data, I suppose, like for the average person, so what can we really achieve? Like, why do we need to store all of this data? What can we really achieve with all these petabytes of data, of stored data, that we cannot do with terabytes of data? Like, why do we need to store so much data?
That's a good question. I think there are different classes of challenges, right? So as we've seen with models like GPT-3, which is a new language model that's been trained on an enormous data set, I think it's clear that there are some benefits when it comes to things like language and vision, where specifically pictures and video, where having extremely large data sets is very, very useful to have a model that can capture all of the complexity that we see in the real world. So I think when you're talking about language or vision, those are extremely complex cases, where it probably does, it appears as though the models benefit from having enormous inputs. But I think most of the cases are not like that. Most of the business impact cases that we see, the data sets don't have to be that large. That the model training does not have to be that sophisticated to show improvement. We everywhere in the business we see opportunity to improve the efficiency of the business. And for me, that's really about like allowing people to be freed up to focus on things that matter. If you think back, before Excel existed, think to like how people would have to run a business on paper without having the tools that Excel provides, right? And so for me, AI everywhere in a business, it's a similar transformation. It's providing tools that allow people to make really efficient decision making, so then they can focus on what matters, which is dealing with the customer, inventing a new product, building a great team, hiring. Like that's where we need to focus our energy, not on the accounting on paper, which is where we are today in many, many, many parts of the business. So for me, I think it's true that there are some cases where, like for us, probably the case is we have some language cases, right? Because we're a company that carries voice traffic, and for us, it's really about understanding the customer is where the speech models are useful. The other area where we have a lot of data is in the network, and so to be able to train a large model to detect anomalies in the network, it could be an intrusion, could be a hacker, but it's more likely that something's wrong in the network. And if we can detect that early by having a sophisticated model, then we can fix the problem before anybody ever notices. And so that's also that's great for our efficiency. It's great for the customer. But those models are terabytes. Those aren't petabyte models. The petabyte models are the really enormous language models and vision models.
Yeah, and they are mostly exception use cases, and so they may offer us enormous things that were thought to be impossible to do that are now possible to do. But at the same time, these are more specific use cases. They are not the 80% of the world. And we also know that data in itself is not the most important part. Algorithms are not the most important part. It's the use cases we use them in.
Yeah.
And in that case, I would love to ask you, so what would be the 3 strongest points that companies and data scientists should focus on to help improve people's lives as efficiently as possible using data and machine learning?
That's a great question. So for me, the first thing for businesses is making your customers happy. And so for me, it's about all the different touch points you have with your customers. How do you make them better? Can you better understand what they're trying to tell you when they write to you or when they speak to you? Can you better predict what offer may be appealing to them? And for me, that's not just about good marketing. That's actually about making them feel like you understand who they are and that you're serving them well. So for me, that's really fundamental. I think for me, the second point is about efficiency of your operation. And it's the point I was making earlier about Excel. Like, identify the parts of your business where if you can improve the efficiency, you can enable the people working in that area to be more focused on their job, what's important in their job. So can you enable the engineers to spend less time worrying about data access control and focus on building great models? It's the same with accounting teams. Can you help them to be more efficient so they focus on what's the future business model of the business as opposed to worrying about understanding why there's these anomalies in the budget. So for me, that's the second point. And the third point is about the earth. Like I honestly, I think, I hope that the COVID crisis has been horrible. One of the things I hope is the kind of silver lining is that people recognize that there are these issues that are bigger than us as individuals that can really impact the whole world, and climate is it. And so I hope that certainly, at Orange, we spent a lot of time and energy on this, and there's a lot of great research in efficient AI. But I think we need to be careful, and we need to do our part to make sure that the work that we're doing is not too greedy. To your title of my talk.
No, and that's actually I'm seeing a lot of initiatives working on that, and we've seen how when used in a good way, AI can be enormous and do tremendous good impact. So hopefully more people will work on projects like that.
It's the balance, right? It's just like delivering a 5G network, right? We need to give people faster connectivity, but we need to find a way to do it in a way that's efficient and isn't too power consumptive and resource consumptive. So it's that balance. I think that balance is the third point.
And that's why you said it, efficiency. So efficient AI, that's one of the things that we should, that the world and research industry should focus on. How can we do more with less? So yeah, hopefully we can get that. And I would love to ask you one last question, which is, I think, very few people can answer. So I really want to ask it to you, since we have a global view of this. So from your perspective, what does the world need most now? Is it data storage, compression, stronger analytics, or better ways to model enormous data? What do you think the world needs the most so that you can achieve what we've been talking about?
I think it's none of the things you mentioned. I think it's this workflow that I talked about earlier. Like, we're at the very early days of having AI everywhere. And right now, there's so much that we have to do that's putting things together by hand. If you think back to what it was like before Amazon existed, or before Google Suite existed, we're trying to basically everyone's trying to build their own e-commerce site from scratch. That's what the state of ML and AI is for most people in the world. And so I think it's about these workflow environments that make it much easier for people to focus on what's important and to hide the complexity for them, and also to protect them internally and externally against things like mistakes in data privacy, security breaches, access control, auditability, and so on. And this is where we see a lot. I mean, if I look at the roadmaps of Microsoft and Amazon and Huawei and Google, that's what the roadmap's about. It's about how to make the end-to-end workflow a lot easier and a lot more predictable and more efficient. And I think that's really the next challenge.
All right, that's an interesting point of that. Yeah, I did not think this perspective, but that is one interesting point of view. All right, so thank you. I'm waiting for a question, but all I've been seeing now is just gratification message, like thank you so much for this information, etc. So I guess you did a really awesome job because you gave us a new perspective, a point of view on that. And with this, I would love to thank you so much, Steve, for being with us in this panel. Your input has been very much valuable for us. And if you, the audience, have been attentive, Steve has talked about Google Cloud. And he talked about the benefits of working on the Google Cloud and what you can achieve with that. And that is what we're going to now detail with Clément Moutet from Google Cloud, which will now talk to us and present to us why going cloud might be a better option for many people, what are the benefits, and what can we achieve using a cloud platform that we can maybe fail to do with our own hardware. So with this, thank you so much again, Mr. Steve. You're welcome to stay with us if you want.
I will stay.
Oh, perfect.
Yeah, I have to say, a lot of my career has been in connectivity in Africa, and so it's a continent that's really close to my heart, and I think it's not only the continent of the next 100 years in economics, but I think it's also the opportunity for Africa to leapfrog in many domains, including AI, is a great one. So I'm happy to be here and happy to listen.
We are also happy to have you with us here. And so with no further ado, are you with us, Clément?
Hello, everybody. You can hear me?
Yes, we do.
Perfect. First of all, you can hear me, but you cannot see me. So sorry in advance. I couldn't figure out how to make my camera work this time, but it's not. It shouldn't be a big problem because I want to present you things. So I think you are more interested in what I want to present than to see me. So can you see my screen?
Yes, we do.
Perfect. Perfect. So what I'm going to do is to give something a little bit practical. It was going to be a practical presentation. For me, my role, I am a customer engineer, which is like technical sales role, something like this. Like the goal is to be able to explain what we do in a technical point of view. And I'm going to present you something about like AI and infrastructure. I think maybe I'm going to repeat things that have been said before. Sorry in advance for that. But I will try to do it differently. So I think you know it after this week. AI is everywhere. You have AI everywhere. So here are obvious examples, but you also have it when you navigate in your Facebook feed, when you are recommended products, when in many use cases in the predictive text that we saw before, and it's everywhere in the software of the big tech like Google, which I belong, but also Amazon, Microsoft, Orange, everything, but also on companies, more and more on companies that were not used to do machine learning before. So as an example, we have Rolls-Royce, which they don't do only cars, they also do boats, and they want to make them autonomous. But Rolls-Royce is not a traditional machine learning company, so they had to reinvent themselves. HSBC that wanted to do a fraud detection in order to prevent illegal movement of money, or eBay to transform user experience by, I don't know, suggesting products that are relevant to someone, and many use cases. Actually, it's more and more difficult to find a business that will not have an AI use case in the future. And for this, there is a need of an IT infrastructure for doing all these computations, because AI is very greedy, needs a lot of computing power. So you need for this to have data center, which are very costly, but not only data center, also train staff to operate them, because you cannot just let your data center like live their life isolated, and to update them for security reasons, for I don't know, new innovation in machine learning. And since machine learning field change almost every 3 years, there is a need to update the system, the underlying system as well, etc., etc. So this is a burden, a traditional burden to this non-native IT companies or non-native IT organizations in general. And so this is what we want to offer in Google Cloud, but in every cloud provider has the same approach. It can be Microsoft Azure, can be Orange Cloud, can be everything. The goal is to be to offer an infrastructure to rent, like virtual machines or computing power or many things that we're going to see, to be like, first, of course, more flexible, more scalable. Like if I want to do a training, I can have all the machines that I want, and then I can disable them once I finish my training my model, to be open and hybrid, like the most compatible possible with open source software, like as said before, like TensorFlow, Kubeflow, and also non-AI softwares, open source software, but in the AI, scikit-learn, etc. This infrastructure has to be compatible. Of course, it's compatible because everything is compatible in IT, but easily compatible. Like you don't have to configure it and to spend a lot of time to make it run. To be intuitive, it has a link with compatibility. To be of high quality, that the machine don't go down, that it's fast to turn on, etc., etc., and secure, because it's in a more and more interconnected world. of course, there is more and more security issues. So there is a need to protect all of that. So in I'm going to present like start my presentation with like the 5 main use case of cloud. So the first one is cheap compute power. Like it's the basis of all the cloud offerings. I want to have a virtual machine. I can have it quickly for not a high price, and also to have it only 1 hour, so I can pay €1, €2 for this hour instead of buying or dollars, or of buying a whole computer and then just to save money. This is the main value offering. The second one, which is relevant to machine learning needs a lot of data, and big amount of data. So there used to be issues with the data storage, because when you have a huge amount of data, you want to store it, but also you want to be able to access it easily. So there is a need to have an underlying technology to be able to access this data that is on this part of the infrastructure and this data that is on that part of the infrastructure, to do aggregation with this data. So there is a strong technology need, and the same with compute need of elasticity. The need that, because it's not always predictable, the amount of data that we're going to have. Maybe, I don't know, tomorrow you're going to put a new captor or new sensor somewhere that's going to take some data that you want to feed to your machine learning model. This data will be additional to the amount of data that you have before, and thus you will have to have the storage solution that in a non-cloud infrastructure you would have needed to have predicted that, to have ordered the hard drives and etc. In cloud, since it's already available for renting in the internet, you will just need to put it on the cloud, and it's going to be easy to do. It has a link with the 2 points before, but there is the technologies, of course, hardware storage technologies, but also all kind of technologies, of AI technologies. I'm going to present some of them later, but the AI domain being more and more on the spotlight, I guess, there is a variety of technologies, of subfields of AI, like AI for vision, AI for sound, AI for etc. And then there is a cardinality of technologies that is augmenting, and there is thus a need for companies to have access to this technology, because companies cannot be expert in every one of these technologies. They cannot all be expert in AI, and even if they are expert in AI, they cannot be expert in all the subfields of AI. So the cloud provider more and more are proposing technologies to rent, like you would rent storage or compute. You can rent a technology for some use case. And last but not least, cybersecurity and compliance tool, because we are first, for security, we are, as said, under constant attack in an interconnected world. And more, since we are manipulating data, moreover in machine learning, we are manipulating data, there is strong privacy, in general compliance issues, and thus an advantage of having a cloud provider is that since the data compliance issues are almost the same around the different, they are very similar, at least around, well, they are not, depends on the industry, but they are more similar between two customers of a cloud provider than between two companies that would operate their own infrastructure. Why? Because these two companies, maybe they have different business. So there, the compliance needs will be different depending on the businesses. But they will have the same underlying infrastructure, the same way of organizing the compute resources, and then there is they can at least I would say check the box for the regulation that apply to how the infrastructure is organized. For example, I don't know, a way to store the data, this kind of issues, and then because they check the box on this part of the compliance map, they can focus to being compliant on their on the laws that regulate their particular business. For example, in finance, the laws that protect the payment industry, that regulate the payment industry, etc., etc. So this is the last advantage. In general, like the demand of compute power, especially in AI, has been exponential, as you can see on the right. It's the number of compute power needed to train some models that are just at least part of state of the art of their time, and it's a in compute. It's a logarithmic scale, so in reality, it's exponential. And what we can see is that even if there have been tremendous progress in performance improvements, the augmentation of performance is not exponential anymore. It is not. Like unfortunately, the Moore's law is what is called the Moore's law, which claims that compute power would double like every year or every 2 years or so, is getting, at least we can say, it's getting slower. Like the compute power is not as exponential as it was before. So of course there is a need to have cheaper and cheaper compute power, because we cannot rely on the fact that the compute power will be cheaper in 2 years anymore. It's not possible. And also what we need is specialized chips. There have been a presentation of nvidia in the morning, which is a great way of handling that, because it's presented a way to continue to have the Moore's law is to have hardware that is specialized for some task. Graphical processing units, even if they used to be, as their name say, like specialized in computer graphics, they are more and more like re-specializing themselves in machine learning, or maybe double specializing themselves in machine learning and computer graphic. And what we can see is also chips or hardware that is specialized only in machine learning. At Google we have, but there is other ones, but at Google we have the TPU, the TensorFlow processing units, which are like chips that are specialized for running models that are made, AI models that are made in TensorFlow. And the research, we are researching to expand the compatibility of this TensorFlow processing unit to non-TensorFlow languages like PyTorch, for example. And it's considered that at Google we couldn't have reached the maturity in AI that we have now without this TensorFlow processing units that are powering almost all of our machine learning system in Gmail and in consumer YouTube and in consumer product in general, because we couldn't have made as many predictions as we do today on the non-TPU chips, even if now this is in the past, but now nvidia is with GPU is catching up, of course, and there is now a kind of competition between GPU and TPU. But in the last 10 years, we at least at Google we needed this specialization. We can still use CPU, computer processing units, which are powering like the traditional computers, but it's more and more difficult to use them for training. I think all practitioners here they have the experience that it's difficult to train a deep learning network on CPUs for now, but we can still use them for prediction the use case of prediction, because prediction doesn't consume a lot of processing power per prediction. But it's not possible to do that if you have to predict billions of if you have to make 1 billion of predictions. The advantage of cloud on this point is that these chips, graphical processing unit and TensorFlow processing unit, are expensive. I mean, maybe the less expensive is $500, but the most expensive can be 15,000 or this kind of price. And if we want to use them only for prediction, only for training, sorry, it's a cost-efficient model would be to rent them to the cloud provider. Even the TensorFlow processing units, they cost like $15K as well. So it's difficult to imagine that they can be like used by many companies that would buy them. And the cloud is a perfect alternative too, because we can rent them for 1 hour, train our model, and then release them, and then pay a reasonable amount of price. Also, an advantage of going into cloud is that, as mentioned before, is that since climate issues are becoming more and more important, they are important this year more than last year. Last year they were more important than the year before, and in 10 years at Google, we believe it's going to be central, and everybody has to plan accordingly for the planet, of course, but also on a regulatory point of view, because we can see now with carbon markets or this kind of initiative that at least we can guess that in 10 years, businesses that will be greener than others will have incentives from public sector. Incentives that can vary, of course, depending on the legislation, but it's very reasonable we think, at least at Google, it's reasonable to think that. And this is something very hard to achieve, because you need expertise. It's not easy to focus in the same time in AI, which is very complex, and also to focus in how to be green. And this is why we try to like offload this from businesses and from cloud users by making our server greener. What a milestone that we have is that now in Google Cloud, since 2017, all the electricity we consume, we buy as much electricity as we consume. Why it is said in this way? It's because there is a problem with renewable energy, at least now, which is like they have a high variability. There is not always wind, there is not always sun, and there is different milestone to achieve. The first one being carbon neutral. So for every ton of CO2 that I emit, I subsidize a project that will capture the CO2, this ton of CO2, like by planting a forest or by making energy reduction in some industry. This is the first milestone. Second milestone is the one we reach, is that because we are connected in a grid, electricity grid that is shared by many stakeholders, is to, for each ton of CO2, for each megawatts of electricity that we take from this grid, we inject 1 megawatt of electricity in this grid that come from renewable energy. So this is the second milestone. And the last milestone that we want to reach in 2030, which is, of course, the most difficult to have, is to have constant matching of renewable and consumption, meaning that if we consume at some point of the day X megawatt of electricity, we will be producing at this exact amount of time the same amount of megawatts, no matter the wind or the sun or everything. And this can be achieved. There is many ways to achieve that. It's of course, research is ongoing. One of the way to achieve that is to have a transfer workloads that are compute intensive, but that are not urgent. For example, I don't know, recommending YouTube videos or this kind of thing you don't need to do it in real time. You can pre-compute a list of recommended YouTube video or whatever, and then serve it the next day. And to save all these workloads and only execute them in region of the world, in time zone where there is a lot of sun and a lot of wind. So it's a way of doing that, but of course it's not. There is not one magical solution. It will be a mix of many small improvements. But at least for now, we reached this milestone, and all the cloud customer can take advantage from it. The second milestone that we have is in renewable is PUE, which is the measure of consumption in data centers of electricity consumption that is not made on IT, meaning that all the things around, like cooling system, lights, everything. And the goal is to be the lower it is, the more it means that all the electricity that is injected in the data center is used for actual computation and not for other things that are necessary to computation, but that are not computations themselves. And it's same as with constant renewable matching. It's not one technology. It's a mix of many technologies that need to converge. One of the technologies that we have at Google is a machine learning model that automatically organizes the cooling by taking different indicators that allow to spend less energy in cooling, and then just because there is less energy consumed in cooling, there is the amount, of course, of energy consumed by the data center decrease, but also the ratio of electricity that is used, or the ratio electricity used by total data center divided by electricity used for computation goes down, because there is less energy used for cooling. So it's one of the big advantages to use cloud to have all these things that are managed by the cloud provider, and just to be green without having without having expertise, and allowing of same with security, same with compliance, to focus to spend the time that we have in developing great machine learning models, or focusing on the business in general. So now we spoke about the infrastructure in general, and but there is not only infrastructure in AI. AI is also a team sport. There is many different jobs in AI. The ML engineers, the data engineers. There is also software engineer to integrate this into apps. The data scientist, the analyst that presents that to the business, of course, the user. And all of these people, here I presented 6, but there is many more. And because AI is always changing, there will be more. And all of these people, they don't have the same skills. They don't have the same goals. They are not using AI in the same way. And moreover, even in developing an AI model, there is different time. There is different moments. Like you need to first define how data will be structured, then to analyze what data you're going to use for your model, then of training, create model, select model, configure it. Then once you have the model, to evaluate it, and then when you evaluate it, to deploy it to production for making prediction in a scalable way. So all of these people and all of these different steps of an AI model need to be synchronized, and what we can see is more and more the apparition of the appearance of the emergence of collaborative platforms. We have at Google bought the Kaggle collaborative platform. We launched AI Hub, an internal AI hub, but there is many other solutions in the market. But all of these solutions, they have the common point that they need to synchronize different steps in the creation of AI and different populations of people that will use this AI. And this is on the customer, on the user side, and on the backend side, they need to integrate deeply with the infrastructure because there is a need, for example, for a data engineer or to be able to execute easily a fast number of computation, or for a data analyst also. And the software needs to translate his instruction to computations and to manage this computation in a way that is efficient and cost efficient, and etc. etc.
Clément, I have a question.
Yes.
Sorry for interrupting, but I have a question that goes perfectly in this slide, which is cost-effective thing. Now, I would love to ask you, and I'm sorry that I interrupted because we are a bit tight on time. What companies, from your experience, so as a custom engineer, I'm sure you have talked to so many companies and shown them all of this. So I would love to ask you two questions, actually. The first one is, what companies or what type of companies or what field they work on need this the most? So who would be the perfect persona type of companies that need a cloud platform and cloud service? And the second would be, from your experience, what cloud APIs should every company use to get more return on investment and a better understanding of their business? So these two questions, I would love if you could give us an answer from your experience.
Yes. So you mean, so for the API point of view, I am not sure. I think it will change. I have some ideas in mind, but it will change. I think with time, what we can see, some APIs that are. I wanted to talk them after is the documents. There is what I can see is that many companies are interested in read document automatically. It's a use case that is very common. It's in banking. You can see it in retail. You can see it in healthcare for medical prescription, but it's traditionally a problem that is very hard because you have many steps that are very complicated, and I can see this use case coming, and it's not a surprise that there is more and more solution on this one. And the second one is the contact center AI. Automatizing contact center responses with a workflow like a user call, then automatic agent answers like what do you want, qualifies the call, and then either answer if the agent can, either redirect it to a specialist if it cannot. This seems simple, but it needs like voice analysis. It needs to acquire specific knowledge from the company, and yeah, I can see this kind of use case. And the first question is, could you remind me what was?
Yes. So from your experience, who would be the perfect type of customer for a Google Cloud platform? So what type of company or startups? Is it in the type of startups that's still starting, or is it the type of startups that work in healthcare or in IoT? So do you have any, do you suggest any type of startup to use Google Cloud platform?
To be honest, I don't think there is a particular type of customer. Why? Because even if at the beginning of cloud in 2010, 2011, it was something used by tech startup, by digital native, this kind of thing. Now it's a lot of people in bigger companies or in almost every industry saw the potential of innovation of AI and of cloud in general. And because they have strong capacities of, but they can be big clients, of course, but the cloud companies have invested in solutions that are typed for this kind of giant. So now we cannot have a hybrid offer, which I think I gave some taste here, because you have all the very technical thing with all the framework, TensorFlow, everything, which is like the core, the traditional fact. But you also have this APIs of machine learning, but also on non-machine learning side, a way to to host all the software that is traditional to a company. SAP being a good example. All major cloud customers now have a way to store SAP, to store the databases like Teradata, or the things that the enterprise have. So now I would not say there is a particular, I would not say there is a particular kind of customer, because of the fact that cloud provider invested for all kind of industry.
Yeah, all right. So any type of startup will find what they are looking for in Google Cloud Platform. All right. We would love to learn more. There's so many interesting things about cloud computing in itself, but sadly we have a schedule to follow. We need to move on to the next panel. So thank you so much, Clément, for your presentation, for the effort, and for your time, especially.
Thank you very much.
Thank you. You are also free to stay with us if you want, because now we are moving on to the third and last panel of today, and which also is going to be the last panel of AI Africa Week. It has been an awesome week. It has been like a huge event. Like we had more attendees and supporters than we imagined. And now it is time to end it in a big bang with our last panel, which will be discussing the real future. Now, we have been talking that AI and data is going to be the future, but nah, it's already present, it's already here, and the real future is what's coming next and how it can lead to help AI. And so without further ado, I'm pleased to introduce to you our speakers for the third panel, which is next generation computing and infrastructure. Mr. Sangudi Brian from Orange, which is the Director of Innovation at Orange Middle East and Africa, as well as Mr. Olivier Hess from IBM, which is the Executive Technical Leader and IBM Q Ambassador. Hello.
Hello, Elias, and hello, Olivier.
Hello,
glad to be here.
Good morning. Nice to be here too.
Morning. And just side note, Olivier, I love your background.
I'm promoting quantum computing.
Indeed.
That's perfect. We're really glad to have both of you with us today. I don't think you can manage to get better people to talk about the subjects of today, which are going to be, or should I not tell us? Should I make some suspense for the audience? So I would love to just give some information to the audience. If you've ever heard of quantum computing, or if you've ever thought about 5G and what it really is and how it differs from the rest, well, today in this hour we will be answering all your questions, and we will first start with a small introduction from our guests to better know them. Then we will go straight into it. So who would love to start?
Great. So I can introduce myself. I'm Brian Sangudi, Chief Innovation Officer for Orange Middle East Africa. And my background is really actually also computer science, but right now my role, I focus on innovation. So this means bringing to market the next sort of evolution of solutions. This is innovation in terms of technology, its application, business models, delivery, etc. So that's what I do, and I'll be speaking to you. I'm glad to be here today with Olivier and Elias.
Thank you. We're glad to. Mr. Olivier?
Thank you. So good morning, everyone. So my name is Olivier. I'm based in France, and I'm leading for IBM the quantum activities for France, meaning the main objective being to promote or to infuse, I would say, this new technology to our partners and customers and help them understand what will be, I would say, near future, the benefit of using a quantum computer. And just by the way, we in France have a quantum computing center based in Montpellier, and we have a group of people really dedicated to this activity and promoting, again, quantum computing in France and in Europe.
That's awesome to hear. Now, can we give a better idea to our audience about what 5G really is and what quantum computing really is? So
Okay.
I would love to start this time with you, Olivier, if you can give us a better idea of what it is and how it differs from traditional computing.
Sure. In a few words, we all know that a classical computer uses a bit, and a bit can be 0 and 1. This is the classical theory of information, and over the last 15, 60 years, we're able to define a theory of information based on bits. We know how to store bits, we know how to compare bits, we know how to add bits. In a quantum computer, we are building the same idea, but the main idea is to use a new branch of physics called quantum mechanics. And with quantum mechanics, we will exhibit, I would say, new properties well known as entanglement and superposition. In a few words, what does it mean? As I said, in a bit, a classical bit can be 0 and 1. When you are in the quantum world, a state can be 0 and 1, but something between 0 and 1, meaning that at the same time, a qubit, a quantum bit, can not only represent two states, but a kind of infinite number of states between 0 and 1. And the main idea to the flavor is that when you have a very complex problem, at the same time, the qubit can handle many parameters at the same time, compared to a classical bit when you have only two states at the same time. And this is where the power of a quantum computer comes from, this capacity to represent a huge number of parameters where a classical computer is, I would say, limited to 2.
All right, so it will allow us to hold much more information at the same time, and this will allow us then to have better computational power. And
exactly.
Wow. And how if we can put a number on it, like how much faster is it to compare to traditional?
It could be millions of time. It could be millions or multi-millions of time. And I think maybe we'll get back to this in a few minutes, but the power of quantum computer is exponential with the number of qubits, meaning when you have many qubits, the capacity will be exponentially high, meaning that with a quantum computer, the advantage and the boost will be hundreds, millions of times faster to a classical one. And this is where we can tackle problems where a classical computer will take months and years and millions of years. This problem on a quantum computer will be solved in a few minutes.
Wow. So that's how we can make spaceships in the future.
Exactly.
Wow.
And really, this opens to solve problems which are really inaccessible to classical computers. And this is something we may discuss later on, is the use cases and what kind of problem, what kind of advantage we will take from a quantum computer in the midterm.
And the thing is, so computing power will be exponentially higher, but also we need to feed it enormous amounts of data to process. And
exactly.
In that case, we would need something that allows us to feed enormous amounts of data at near real time, which I would guess would be the 5G.
Yes, your guess is right. So no, it's interesting, really interesting to hear about the difference between quantum computers and traditional computers. I think many people know, are familiar, Olivier, you might agree with Moore's law about how the number of transistors increases, with regularity every year. So I guess quantum computing takes this to another level of growth. It's not just linear growth in transistor counts per square inch or centimeter or whatever, but it's really a difference. So that's opens up new possibilities for sure. 5G similarly is such a shift. Okay, so 5G stands for the 5th generation of wireless communications, right? Cell networks, 5th generation. But though the name is 5G, it's not as simple an evolution as previous generations, right? So for sure, it's much faster. Multi-gigabit speeds are possible with 5G that weren't before. It's also much more flexible. So by flexibility, what we mean is that all these generations of wireless computing are defined through standards. A group of companies get together and engineers, scientists get together and define these standards for wireless communications. This 5G is defined by new standards, but new ways of using the network. And the most important one I would say would be network slicing. Okay. When we talk about network slicing, it means that you're able to use the same network in multiple different ways. It's almost like creating a piece of the network that you use in one way versus another piece that you use in a different way. If I want, for example, to watch a movie, what is most important would be the bandwidth, how much data can flow through the pipe, right? This will allow me to watch a more high definition movie, etc. Okay, that's what matters there. However, if I want to drive a car remotely or operate a machine remotely, what matters there is not the volume of data that can flow through, but the speed with which the data can flow through. So 5G allows for much better standardized definition of these standards for slicing a network. This allows also new possibilities that we can discuss later, but that is a key generational difference between 5G and everything that came before it. So new possibilities are going to be opened up, including the possibility to feed quantum computing a vast amount of data from multiple points, multiple places remotely, as well as to process anything coming out of quantum computing, a quantum computing center or resource to where it's needed. Yeah.
Nice. So 5G would allow even would allow high speed and high bandwidth connectivity to even to autonomous, let's say, and IoT devices are really far away from Wi-Fi and from a traditional network, and would allow them to get really high quality connectivity at that, which would then allow us to explore more and do more in the vast majority of Earth without needing grids and Wi-Fi. Now that's interesting. Yes. Now let's go more in depth into the opportunities that both of these technologies can offer to us. And I think since we already started with 5G, let's finish with the data side, because I'm sure we're gonna be finding so many use cases on the data side, and then we're gonna go on the computing side with Olivier. So Brian?
Yeah. So I mean, I think there are multiple ways we can apply 5G, especially its unique abilities with quantum computing to realize certain new possibilities. Okay. So for example, we can say that if you look at the sort of real world, the physical world, and you need to gather data on the physical world for any application, for any use, right? This is where 5G can really shine, right? So if you need to do weather modeling, for example, right? If you need to build a weather model, whether that's regional or global, and it requires you pulling data from multiple data points spread all over the place, you probably want to have a wireless network so that you really are able to pull data from many places. You probably would want to bring this data to a central location to process it because obviously there are many different indicators and you need to look at everything together to know and to model weather. So that is something that again would be possible uniquely via something like 5G, where you want vast amounts of data fed quickly to a central location and then processed. That's one such application. There are resource management applications, whether it's natural resources, like the weather, or other resources that you want to manage. This allows you that flexibility where you have multiple points of data for you to manage. There's natural language processing. There are many such places where you really are able to leverage 5G. But I'm curious to hear also about sort of some of the use cases for quantum computing, and I think that will shed even more light about how these two things work together to realize use cases.
Sure. And they will. And they will. Coming back to, sorry. Coming back to quantum computing. The first point is that to understand that the main objective here is not to replace classical computer. I mean, classical computer will still exist and will still run with their classical workload. And what we're doing is to identify what are the problems, what are the algorithms which are eligible to quantum computers. In a math, and I won't bother you with this, the problem are called P or NP complex, meaning that when you will double the size of the problem, and in particular, when you double the amount of data needed for a given problem, in a classical computer, the complexity will be linear. For quantum computing, we are addressing and tackling problems with an exponential behavior, meaning that when you double the size of the problem, the complexity will be hundreds, thousands, millions of times bigger. And this is exactly in this field where a quantum computer will provide its capacity to solve very complex problems. And as you said, Brian, there we will need, of course, the capacity to feed, I would say, the quantum computer with data. And this is key. Of course, we are not there yet. We are not yet there at the level to solve a real problem. But in the near future, of course, we would need, first of all, to identify problems eligible to quantum computer, but also capacity, again, to feed quantum computer with high-speed network. And I guess 5G could be one solution there.
Mm-hmm. Yeah, I mean, go ahead, Elias.
I just said, so I was talking out loud, saying interesting.
Yeah. No, for sure. I mean, for me, I think about quantum computing's application towards even pharmaceuticals research, right? Where, of course, there's a lot of laboratory work, but maybe there's also data feeds, data points from around the world, or from a field, if you would. 5G certainly would enable that. Another one that's related, maybe a medical use case that I would say is much more relevant for 5G would be even remote surgery, right? Sort of telemedicine, but specifically surgery, where if you have a doctor performing a remote, but very fast flow of data. So there are many such, I think, use cases, some much more pertinent to quantum computing, others much more pertinent to 5G, but many as well where they work hand in hand, where 5G is a delivery method, a highway, and then quantum computing can really move solutions across the board when the data is delivered to it to compute on.
I have a question about fields. Sorry to interrupt, Olivier.
No, just one word, and this is even important, that today and tomorrow, by the way, quantum computer will be hosted in the cloud. The objective is not to sell on-site quantum computers, meaning that for end user, the main objective will be to access remotely a quantum computer, and this is where high-speed network and 5G and this technology will be key in the way to address and to solve real problem on a quantum computer.
Even though I would love to have that computer behind me, but like you do.
we don't sell it.
Yeah. In that case, I would have to work for IBM in that case. So I would love to talk more about the fields or the specialties that will most likely or most benefit from both 5G and quantum computing. For example, many have said that cybersecurity is at risk because of quantum computing speed. So it can brute force everything, or it can calculate so many things. Math and physics modelization also are waiting for this because of so many calculations can do. And for 5G, many say that a smart city can only be smart with 5G, with so many interconnected devices that flow at the same time. So what else? So first of all, do you agree about smart cities, cybersecurity, and math physics? And if yes, what other fields or what other domains will most benefit from these technologies?
Olivier, what do you think? Do you want to take a pass?
So I will go first. So you're right, Elias, and the point we outlined are very true. But I would say there are many more. And what we are doing at IBM and also other companies is to work with different partners, industry, academics. And the main objective here is, again, to identify what are the problems eligible to quantum computing. And there are many problems like this. And in particular, we as IBM, we are developing a tool called Qiskit. And Qiskit is the IBM development kit for quantum computing. And in this Qiskit, it's structured around AI, finance, chemistry, and algorithm. And what we do within this worldwide initiative called IBM Q Network is to work again with large companies in different fields and to identify industry by industry what kind of problem would take benefit of a quantum computer in the near term. Today, we see different levels. Finance and banking is for sure a level, a domain where a quantum computer will provide a real advantage. Also logistic, and this is close to smarter cities, by the way. You have a city and you like to treat all the cities at the same time. Of course, we have also chemistry and life science, the development of new material. We would have, for example, a partnership in the US with Daimler brands, and the main objective here is to identify new material, new molecules for batteries, and this is key in the development of electrical vehicle. And for sure, there are many domains, logistic, aerospace, where again you find this problem with a relevant complexity, which are eligible to quantum computing. And again, this is a key activity we do have in this IBM Q network, working with partners and identifying field by field what are the problems for these.
Excellent. And I will just to add to what Olivier said, and those are very relevant use cases that Olivier mentioned there. And I'll just add to that what the relevance is for 5G, what role 5G can play in such work. But first, to broaden the number of use cases. So even when Olivier mentions molecular research, right, for materials research, material science to develop better batteries, this has a broad-based impact, right? So yes, batteries for electric cars, as Olivier said, to make, of course, to improve things around the world, but also even batteries that are used for solar kits, right? For solarization right, in emerging markets like many found in Africa. So we sell solar kits all over the region, but of course there's always this search for a better battery, because storage is a huge problem for electrification. But material science also covers things like research for medicines, right? So right now we have the COVID pandemic we're living through, right? So finding a COVID pandemic cure also taps into computing power, right? So with quantum computing, with that possibility, we might be able to solve such situations a lot faster, right? And as Olivier mentioned, something that's critical, something very important. If we're not gonna each have a small personal quantum computer in our pocket or something like that, if it's going to be a centralized resource, then obviously many people around the world will benefit from being able to access that resource. So basically, you can think of 5G as not only delivering data to the quantum computer, but more or less lending the quantum computer to the researcher, wherever the researcher is in the world. So anyone in any research center around the world can borrow time on the quantum computer to do research on certain domain areas, whether it be material science for batteries, chemistry for medical cures, or anything like that, or even traffic patterns for city to optimize, anything like that, or even, like I said earlier, weather patterns, etc. There are many use cases where you find that quantum computing and 5G would work hand in hand to deliver resources where they're needed to get results.
Again, you were mentioning, Elias, smarter cities. For sure, a smarter city is a key domain, mixing 5G and quantum computers. This is a key challenge here.
I love the word mixing, because we are now going to mix quantum computing and 5G with machine learning and AI. So the audience is also interested to see how both of these technologies will empower AI and will allow us to do more and better. So naturally, the question that many would think is, how can 5G or quantum computing affect AI, and how it can aid to make better application? So some of our audience already thought about, for example, better data handling, better accessibility, better bandwidth, so more data in real time, and more powerful embedded device. And also others would think we will now manage to train models in like minuscule amounts of time compared to before. But I would love to hear it from you, who know much more about this than I do.
Ryan?
Yeah, sure. Okay. So when it comes to AI, I think learning is going to be a very important dimension there. And to the extent that we're applying AI to the natural world, then I think 5G is indeed a very important bridge to pull the data points from that would teach a model, right? To really have this learn, right? It could be something that's not just based on a time series. It could also be just something that's more a longitudinal series, where you just have a broad set of data and you want to learn from this broad set of data. So there are quite a lot of things to be done there. And I think that it's quite relevant in several different domains, wherever we want to really apply AI, whether that's in natural language processing, different kinds of bots, etc. I think that you have both a role for 5G to ensure that data can be, you have the right slices of the network that would allow the important AI to work as intended, and allow for other uses for communications, of course.
Yeah.
Nice.
Exactly. Yeah.
And how about quantum computer? I feel like I'm in the ring, in a boxing ring, and you have 5G, and I say, all right, and now on the other side.
As we all know, AI can be very compute intensive. meaning that certain problems for AI will be relevant to quantum computing. And this is key that over the last, I would say, 3 to 4 years, we see a strong focus on developing algorithm for AI, and in particular for machine learning, what we're calling QML, quantum machine learning. And the main objective here is to identify in this field problem where the complexity there, again, is exponential, and to solve this problem not only with classical computer, but also with a quantum computer. And in particular, and again, I don't want to go deep dive, but solving some AI problem will need to be solved, mean what we're calling BLAS routine, BLAS being basic linear algebra subroutine. And these subroutines are usually very, very intensive for classical computer. And over the last 5 to 6 years again, we see a strong focus on adapting, I would say, this classical BLAS routine to quantum computing. This is called QBLAS, quantum BLAS. And the main objective, again, is to build AI solution around quantum computer. And in particular, we can expect that for the training, quantum computer will be much, much, much faster compared to a classical one. And this is also one advantage of a quantum computer.
That's awesome. Yeah, definitely much more to it than meets the eye. I'm sure in both of them.
Yeah,
so,
yeah.
We could, yeah.
No, just one example. For example, one key example is in different domain is the portfolio optimization, is the data segmentation, and these two problems are well known as being, I would say, eligible to quantum computing, and in particular in finance, in retail, in telco industry, those problems arise, and this is for sure something the quantum computing ecosystem is really deep diving for addressing in midterm these activities and this domain.
Now that's an interesting point. You said the community. So so that brings me to my second point, to my next point actually, which is what infrastructure does one need to use quantum and 5G? So in that case, you said the community, but does all the community have access to the quantum computing online, or is there a way to for example, the Qiskit library? I'm not familiar with it, but is it? Can I try some kind of pseudo quantum computing on my normal machine?
Yes, absolutely. I mean, the Qiskit in the software environment is open source, meaning that everyone can, through the IBM Quantum Experience website, create an account and access real systems in the cloud, and of course use this Qiskit environment. And this is our key strategy, is really to build around our technology an ecosystem of partners with industry, startups, academics, and developing or co-developing use cases, as we discussed. And this is why we are putting in the cloud real systems. And today we have around 20 different systems available in the cloud. We do have this Qiskit you are mentioning in the cloud, letting the community accessing the system, starting developing, building their own algorithm. And the key point is understanding how it is different. I mean, programming a classical computer versus a quantum one. So meaning it's key, and the education and the capacity to build an ecosystem is key for the near user to be eligible for these.
And is it too different, like between the two programming paradigms?
It's totally different. It's totally different, and this is one key difficulty. There is no portability, meaning you have an application running on a classical computer, and there is no way to take it and to put it on a quantum computer and run it. You need to not to rewrite, but to rethink from scratch your algorithm. And this is where the difficulty from an application standpoint comes from, it's not a new language. It's a new way of defining an algorithm and then developing on the system. And this is why, I mean, building an ecosystem, working with students, universities, and private company, just to infuse this this way of programming to their side.
That sounds interesting, Olivier. So I think it's quite interesting to hear how the difference in how you have to think or how you have to present a problem to a quantum computer versus a traditional computer. So there is a learning curve, if you would. But it's good that you're of course outsourcing some of this work so that people can start to sort of
Yes.
pick it up and prepare for it, because I think it is important. Similarly, I think 5G is something where it's a platform, but even with the possibilities it presents in terms of network slicing, etc., applications have to now be developed for it. So we have things like that are sort of pertinent for across the world. Things like we're improving safety, for example, when it comes to machine work, like physical machine work, like mining or deep sea research or things like that, where you're able to work more efficiently remotely, right? By having this super low latency available to you, you're able to replace and simplify a lot of much more complex infrastructure. You're able to do more with less. In fact, it brings me to sort of a question that I had in terms of perhaps efficiency, right? You mentioned how much more powerful a quantum computer is to a normal one, but maybe you can also touch on how much more efficient it is in terms of energy consumption, et cetera, because I do know that for 5G as well, it is something that it keeps getting more and more efficient to transmit the same amount of data. We use less power. It is something that's I think is fairly relevant here as well.
And that's a very good question. And by the way, this is also a key advantage of quantum computing. I mean, as you may know, I mean, when using what we're calling a high performance computing, mean very high-end system, classical system, the power consumption can be close to 1 megawatt. And 1 megawatt is around 1 million euro per year, just by feeding from electricity your system. A quantum computer, the envelope for feeding a quantum computer in terms of energy is extremely low. And meaning the system you have in my back, the average power consumption is around 30 kilowatt compared to megawatt. So this is a key advantage also. I mean the grid at the energy efficiency level of a quantum computer versus a classical one.
Okay. Yeah, I think for 5G, we see similar sort of efficiency improvements, but they also have to be, you have to design sort of solutions to take advantage of them as well. You can transmit a lot more data, whether it's more bandwidth but less but higher latency, or you want less bandwidth but better latency. So you have these options, and really people have to build the applications that lend themselves to one or the other, or some combination of the two.
Yes, exactly.
Live sports, for example, like I was mentioning, remote sort of surgery, telesurgery, if you would. There are many such things that the world opens up with 5G, where it gives you this kind of presence that that really becomes something that's impactful, much more impactful than previous generations. So I think it's the same for quantum computing.
Exactly.
Having that efficiency is really can be a game changer.
Like first of all, I loved how naturally this conversation flowing without me. I didn't even need to ask about the consumption. You asked it yourself. I love how it's going so naturally. And the second thing is, while you were talking about, I was already picturing things. I was already picturing how it would be, and I think we're still underestimating how powerful these technologies can become. Now, for example, you said live surgery, for example, and I was thinking, like, imagine a surgery room, and then you have like a piece of data that's big because real-time 4K in a video that's really that's sent really fast. to a quantum computer, then really fast to get the result back. It can then do the action using machine learning, and it can even then be performed there and then. And it allows us to do much more advanced and efficient use cases. And the best part, it costs even less money because it's more efficient. So I could only like imagine how much better it would be, because especially because of budget constraints and with problems, especially an emergency crisis, for example, crisis management. So if you have a tornado, if you have a volcano, anything that can damage some kind of infrastructure, it can easily be deployed with 5G to try to collect data. Then and then with the cloud, you can then process the data, find some data or some patterns, and then be very efficient. So it like it appears so good. When you think about it, it looks like a sci-fi film. And you can imagine by my stuttering how I'm at the same time thinking of the whole world of it. But the question would be, this is all good, but when do you think these technologies will become available to the public? Like for machine learning, it's already available. For 5G, I think, I'm not an expert, I think that it started being deployed in quantum computing. The community has started working on it. But when will it, and it's just an estimation, of course, become available to the public, the general audience?
For the quantum computing side, as you understand, we are still on the learning curve. And the main objective is to build and to mature real hardware, and of course, to develop software and new application, as we discussed a few minutes ago. We as IBM, we think that in near future, I mean between 3 to 5 years from now, we will be able to demonstrate what we're calling the quantum advantage. What is it? Quantum advantage is the capacity to demonstrate that some problem, some algorithm will be faster on a quantum computer in, again, 3 to 5 years from now, compared to a classical one. And this is why in this IBM-Q network initiative, we are developing the hardware and growing the size of our system. And we plan to have 1,000 qubits in 2 years from now. And in parallel, we are working on the application. What kind of problem will take benefit of these? So 3 to 5 years will be, I would say, the first step, I mean, just demonstrating the advantage of a quantum computer. And then, of course, to have more a generalized system, to have more, I would say, system with coherence and better, I would say, error correction, it would take 10, 15 years from now. So it's the first step is 3 to 5, and then 10 to 15, I would say.
Okay, right.
So, I mean, for 5G storage is a little bit different. Of course, it's already available, already deployed around the world, including in Africa. But I think that its broad-based applicability is still a long ways off, right? So there's still a long way to grow to really have full access where it's needed for technologies like 5G, whether that's like in education, remote learning. You can imagine how education can be revolutionized maybe by having sort of this ability to really have this telepresence where someone can really experience being in a virtual classroom really immersively. And I think that there's many such applications already. For example, for us as a telecommunications company in the region, we have solutions around solar kits. We have education solutions. We're working on e-health. We're working in agri. We're going sort of beyond sort of your traditional services to really look at what multiple services can we offer with partners in the region. And I think that all these things benefit from having really the availability, the more broad availability of 5G in such technologies, and also quantum computing. It's all, to me, boils down to sort of sharing these resources, having them available where they're needed. And I think that, quantum computing is a great sort of computing resource. You need to make it available via 5G if you would. And similarly, there are many applications out there where, for example, many sort of limited, you can say, resources like expertise. Like a medical doctor, his expertise or her expertise may be applicable far from where they physically are. So 5G is an enabler, right, to make this person's expertise available, impactful where it's needed. Similarly, for a great teacher, right, educator, right, can apply that their teaching method anywhere where it's needed, most applicable, most useful around the world, etc. So all these things are, to me, enablers of these things, and of course the creators are the people who are going to pull them together to build the solutions, the applications that can really bring these things to bear.
Now that's interesting. So do we? So I think Olivier, I want to
just one point to add. I mean, I was mentioning this roadmap, but just to be clear, I mean, today we do have a real system in the cloud. We have around, as I said, 20 systems available. Qiskit is open and available. And the main objective here is, as you said, Brian, is to start building the community and to have students, industrial partners starting developing on the system. This is why Qiskit is fully available. And we do have around 20 systems in the cloud just to start the community, start playing with the system and growing the maturity.
Now, since you talk about community, I'm really interested by that. So if anyone here, the audience, wants to join a community and wants to dabble with other people that work on that stuff, so are there any programs, labs, events, anything for both 5G passionate and quantum computing passionate that they can, after this event, check out and why not participate in? So is there anything for our audience? Let's start.
Go ahead, Brian.
Yeah. So no, I was just going to mention that for Orange, for sure, we have something called Orange Digital Centers. We have we have over 70 startups that have been sort of incubated, supported, if you would, through our Orange Digital Centers around the region, around Africa, and we're open to more. So we participate in various startup initiatives around the continent. We invest over €1 billion every year in Africa. So yeah, there's a lot that we engage with people who are so interested to really build on communications, build solutions driven by communications. Absolutely. So they can just reach out to Orange, search for Orange Digital Centers, and really go from there. That's one of our main places where we can take in partners who are so motivated.
Exactly. Yeah. And from my side, as you said, Brian, we do have many activities around education and events. By the way, last year I think we organized in Africa an hackathon on quantum computing. I don't remember exactly where, but I'm sure we did that. We plan to run, I think in the near future, a quantum machine learning event hosted by IBM. And by the way, just for Montpellier, we plan to run again a hackathon in France. And of course, you'll be welcome to attend if needed and if possible. And that's key again to build a community. To access the system and to start playing, and again, as I said before, to infuse this quantum computing, you would say, flavor to end user and industry, startup and academics. So many activities around quantum computing. And by the way, there is a YouTube channel called Qiskit, where you can start playing with Qiskit, understand different algorithms, and in particular, some of them related to AI, and start building and growing your expertise and skills in this field.
Awesome. So there's a lot of resources in place.
Oh, yeah.
So someone can check it out. All right. Well, in this case, we still have 5 minutes left. And in this case, since we've stretched at the start of the panel, I said that machine learning is the present and now 5G and quantum computing are the future. But it seems like even quantum computing and 5G are in the present now. So,
exactly. Yeah.
Yep.
Yep. The future is now, as we say.
Yeah, that's true. The maturity is real. Exactly. Yes. And many progress have been done in quantum computing over the last, I would say, 5 to 10 years. And as you said, this is today available, and you can start playing with quantum computers. Exactly.
So just a reminder for our audience, if you are interested in quantum computing, there's the community of Qiskit and the whole quantum machine learning community around it. If you are interested in 5G, you can check the Orange Digital Centers. And if you're with machine learning, well, there's plenty of resources for that. Now, I would love to ask both of you a final question. Since what we thought, but I also personally thought was going to be the future, turned out to be right in the corner, I would love to ask you both about your expectations regarding your respective technologies in the near and far future. So for example, Olivier gave us a taste, said that in 15 years it will become general public, and it's already here with 5G, but still not globalized yet. At the same time, where do you see will the technology push us forward in the next, in the near and the far future, especially?
So, Olivier, do you want to go first, or should I?
No, go ahead. Sorry.
I was hoping you would give me more time to think of my answer, Olivier, but it's all right. So for 5G, what I expect, honestly, is that it is going to be a great enabler, okay? And the way I'd like to think of it most simply, most generally, is that it will deliver resources where they're needed, okay? This resource could be your subscription. It could be your online learning. It could be your virtual classroom. It could be your family if you're working far away from them. It could be your quantum computer if you're a researcher working to develop the next superconductor material. It could be any of those things. It could be whether you are in transit in a public transport sort of bus or anything like that. Whether you are on a train, whether you are, no matter where you are, what you have with you. It means that everything becomes mobile, right? Mm-hmm. Your resources, your subscriptions, your this, your that. That's what I see as being the possibilities for the future. Even communities, back to communities that Olivier was mentioning. Communities can really, really become much more tangible if people can feel that telepresence and can have that. So those are all things that I expect 5G would enable, of course, in parallel and in partnership with other such technologies like quantum computing.
Yeah, and from my side, I think I'm convinced that tomorrow we will get quantum computing. I mean the technology is growing extremely fast. We see many vendors and actors building systems, and we see the quality of system being more and more higher and higher. So that's for sure that tomorrow we will have, of course, still classical computer, but midterm we will see quantum computer, and what is important to understand that the two systems will coexist. Classical and quantum computing. This is called the hybrid quantum computing side, and the message I would give at the end that this is key, that tomorrow we will have for sure quantum computing, and the main objective is to start now. I mean, if you want to be ready in the near future, if you want to start building your algorithm, if you want to be able to take benefit of a quantum computer, you need to start now, as the growing curve is pretty long. So start now. This will be my message, I would say.
All right, so much hope for this, so much hope for the next generation. I am hyped. I'm personally hyped about this. I'm a technology passionate first, and then machine learning specialist. So when I hear you talk, especially today, I felt like I was watching a YouTube video. It was really like I forget I have to moderate, so I was like, oh, this is really interesting. That's so much happening. There is so much happening, and I'm honestly happy to be part of this, and I'm really happy to have you with us to give us better insight on this, especially for our dear audience. So with this. And I don't know if you have any last words for the panel before I close it.
No, just to thank you for the invite.
Yes, thank you, Elias. You have done a great job. These are interesting topics, and we really appreciate this opportunity.
It was a pleasure. It was a pleasure to be there and share with you.
And all of you. Thank you so much, Olivier. Thank you so much, Brian. Thank you so much for our dear audience, our speakers, our moderators, EV Technologies, and of course, Orange for having helped in the success of the first edition of AI Africa Week. What future for artificial intelligence was our main question? Well, I think there's a lot to uncover, and the thing is, the future is now.
Exactly. It is now.
Exactly.
Absolutely.
Exactly.
So thank you everyone so much for this. We are hyped to see you in the next events because this is not the end. Instead, there's not a new thing. We will be focusing more on training session. There's so much content that has been said in the event that you may not have been able to attend to, and that's why we will be making some more content afterwards to explain that. So we will have many other events, hopefully more speakers and sessions, because we have seen that there's a big interest in these technologies, especially in the African continent by African citizens. So with this, and I'm stalling for time. I don't want to end it, but I think I have to do it. With this,
we can do it again.
Let's do it again. Let's do it together. So for this, I am proud and happy to announce the end of the first edition of AI Africa Week. Thank you again, everyone, for being with us, and hope to see you all in the next sessions. There will be next sessions, and you are free to ask or suggest for sessions in the future. Hopefully, we will be able to hold them. We will be able to find inspiring speakers like our speakers and like Brian and Olivier, and hopefully we'll manage to build together the innovation in the African continent with AI. So without further ado, thank you so much and have an awesome day.
Thank you. Bye-bye.
Thank you, Elias. Thank you, Olivier.
Thank you, Brian. Bye-bye. Thank you.
Bye-bye.